Are you ready for the next method? The next method is called partial fractions, and you'll see why as we go. It's meant for functions which are rational functions. A rational function is some polynomial divided by another polynomial. Say x cubed plus 3x squared plus 2x plus 5 all over, say, x squared plus x plus 1. Okay? Just something out of the top of my head. Okay? Dx. You always need a dx, of course. So I'm going to give you 5 steps, I think it is, which are needed in order to do these problems. And the first step, and again I'm going to be lacking space, so you'll need to remember them as I erase them. But the first step is if the degree of the top is greater than or equal to the degree of the bottom, then you divide the bottom into the top. Remember, the degree is just the highest power of x. So the degree of the top is 3, the degree of the bottom is 2. So how do you divide? There's quite a bit of just algebra in this lesson, and it's all good stuff. So let's go ahead and do it. X cubed plus 3x squared plus 2x plus 5, and that's the degree is 5 and here, or 3, and here degree is 2. So you're going to go x squared plus x plus 1. And so what do? We do it just like we do long division of numbers. We start by saying, well, what do you need to multiply x squared by to get an x cubed? You need to multiply it by x. So you're going to get an x. You multiply out, you're going to get x cubed plus x squared plus x. By the time you've multiplied that all out, then you subtract. And so the way you've done it, this one is going to go away. And you're going to get 3x squared minus x squared is 2x squared plus x. Okay, bring down the next one there. What do you need to multiply this by in order to get a 2x squared? Obviously, you need a 2. So you go plus 2. 2 times this is going to be 2x squared plus 2x plus 2. Subtract, and you're going to get what? Negative x plus 3. So what we've just shown is that this quantity here can be rewritten as x plus 2 plus, here's the remainder, negative x plus 3 all over x squared plus x plus 1. Just like with numbers, right? You have here's this divides into this many times, and there's your remainder. You put the remainder over this. So notice that by the time we're done, we have things here that we can easily find the antiderivative of on their own, and then the thing that we have left, the degree of the top is less than the degree of the bottom. See that? That's what we want. Then we'll take this and run with it in the next step or so. Okay, so the first thing you do, I don't have space to write it down, but if the degree of this is greater than or equal to the degree of this, then you divide, and then after you divide, you'll get some things here, and whatever you have left, that's what you're going to work with. Okay, so then here's the next step. Once you have something that's left, now this degree is always going to be greater than this degree. Then you factor each one as much as possible. So let me just write that down. Most important is to factor the denominator, okay? Step 1, I'll say divide. And number 2, I'll say factor. Okay, now again, this requires quite a bit of algebra. Suppose, for example, that I were to give you this one right here. X to the 5th plus 3x to the 4th minus x cubed minus 5x minus 4x, minus 5x squared minus 4x plus 6. Okay? And so obviously the degree of the bottom is greater than the degree of the top, so now you want to factor the bottom as much as possible. Can you see it just by looking at it? It should be obvious to you that the bottom can be factored into x minus 1 quantity squared times x plus 3 times x squared plus 2x plus 3. Okay? I made a bit of a joke there. It's not at all obvious. Okay? It takes a bit of work to do that. But here's some things you can use at least to try to get yourself off to a good start by way of factoring it. Okay? Well, here's several things. First of all, it's the fundamental theorem of algebra, which says that you give me any polynomial, and that polynomial can be factored into linear terms. A linear term means that you have the highest power of x is just 1, so this is a linear term. Here's another linear term. Here's another linear term. Okay, you got two of them there. They're square, but they're all linear terms. This is a quadratic term, okay? This can't be factored anymore without getting into complex numbers. So if you're going to stay away from complex numbers, that's factored as much as it can be. But that's the key, that any quadratic, or I should say any polynomial, can be factored into linear terms and quadratic terms, okay? And so then it's just a matter of trying to find them if you can, okay? There's no guarantee that they're going to be easy to find. But one good way to start is by saying, what are numbers that divide into 6? If you have a 1 right there, then you look for numbers that divide into 6 and evenly. And so that would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So good things to start with would be to see if, for example, well, let's just try it. Plus 1. Does plus 1 factor into this thing? In other words, if I were to take this thing right here, would x minus 1 divide evenly into it? Yeah, it does, because I've already told you that this is a factor. So apparently, if we were to divide this into this, we would get a nice result up there with 0 remainder. There'd be no remainder, okay? So it would divide evenly into it. Okay, so then we have this now left over, and we say, okay, what divides into this? And if apparently I already know what the answer is, so if you take another x minus 1 and divide it into this result, it's going to divide evenly again, and you're going to get something else there. If you try x plus 2 or x minus 2, nope, it's not going to work. You're going to get a remainder there, so that's not going to work. You put in x minus 3, that's not going to work. You put x plus 3, apparently it will work. Okay, so whatever's left, or you could have started it right here at the beginning. If you go x plus 3, you're going to get a answer with no remainder. So the point is the fact that this thing factors into these. Means that when you divide it into there, you're going to get something with no remainder. Okay, it factors. This is a factor. Just like if 4 is a factor of 12, that means that 4 divides into 12 with there's a remainder of 0. Right? See that? So it's a factor of it. So there's a remainder of 0 there. Okay. So there's various ways to try it out. You can actually start by just dividing this into this and see if it divides. The other thing you can do is notice that since this thing right here is equal to this, they both behave exactly the same way. Notice that if I put a 1 in here, you're going to get a 0 out. Agreed? If you put a 1 in here, this thing will all give you 0. Which means if I put a 1 in here, I'm going to get 0. Let's check it out. If I put a 1 in here, I'm going to get 1. Plus 3 is 4. Minus 1 is 3. 3 minus 5 is negative 2. Negative 2 minus 4 is negative 6. Plus 6 is 0. See that? So one way to check to see if something is a factor or not is by just taking 1 and sticking it in here, and if you get a 0 out, that means that x minus 1 is a factor. Obviously, if I put a negative 3 in here, okay, put a negative 3 in here, do all this stuff, you're going to get a 0 out as well. So those are ways to try to whittle it down into the linear and the quadratic terms. Okay, and that's as much as I'm going to say there. As I say, if you need a lot of help on that, pick up a book on algebra or pre-calculus or whatever to get a little more help. But for our part, I'll assume you got it from there. Okay, once you have factored it as much as possible, then you write it as partial fractions. What does this mean? It's another algebraic thing. All the things I'm teaching you so far is there's no new calculus. It's just a bunch of algebra. But so this is algebra you could have learned early in life. You could have learned this in 8th or 9th or 10th grade. It's just that there was really no reason to learn it until right now. So you're learning a bit of algebra right now. And here's all it is. Say we take, say, 3 over x minus 2 plus, let's make it a negative just to get some negatives, minus 4 over x plus 1. Okay? Let's just take those two things. If you were to get them together into a common fraction, do you agree that the common fraction would be the quantity x plus 1 times x minus 2? Agreed? The common denominator of these things is this times this. So if I were to add them together, I would have to multiply the top and the bottom of this thing by an x plus 1, like so, and I'd have to multiply this thing by an x minus 2. Agreed? Now they have the same denominator. So now that they have the same denominator, I can add them together, and what am I going to get? I'm going to get 3x plus 3, and I'm going to get minus 4x, and then here you're subtract the negative 2 is going to be 4x, what? Plus 8. See that? So if I were to extend it over here, it's going to be what? 8 plus 3 is going to be 11. Minus x all over x plus 1 times x minus 2. Okay, so if I started with this, I could get a common denominator and add them together and end up with this. Let me make sure I've done it right. Looks good. Okay, so partial fractions is just going in the opposite order. It's starting with this and being able to write it in terms of something, you don't know what they are, so something over x plus 1 plus something else over x minus 2. See? So, and why do we want to do it? Because once we have ourselves an integral, and once the degree of the top is less than the degree of the bottom, like this is, then we can basically break it up into, well, first of all, I want to find the antiderivative of this, which I don't know how to do. But the point is, if I can write that as a bunch of individual things, then, hey, no problem. I can find the antiderivative of each of these things easily. It's going to be a logarithm for each of those, right? Natural log. So that's the idea. That's what we want to do. So how do we go about finding A and B? As I say, it's just a bunch of algebra here. How do we find A and B? Well, watch. It's kind of clever. You just multiply through by your denominator. So here you're going to get 11 minus x is equal to, if I multiply through by the whole denominator, it's going to be A times the quantity x minus 2 plus B times the quantity. If I multiply through by the whole denominator, the x minus 2's are cancel, and I'll get an x plus 1. See that? So this means the same as this. Here, I want to find a and b, which make that true. And the a and b, which make that true, have to make it true for any value of x. Okay? This is equal to this. So whatever a and b are, they've got to be equal. They've got to be true for any value of x. So let's choose a couple values of x that are easy to work with. In particular, let's choose x to be equal to 2. If x is equal to 2, this disappears. And so if x is equal to 2, I'm going to get 11 minus 2 is 9 on this side. And I get a 2 right here. 2 plus 1 is 3. 3b on this side. And so, of course, that tells me that b is equal to 3, which is, remember, that's what we had. What's the other one we can do? I can let x be equal to -1. And when x is -1, what do we get? If x is -1, I'm going to get 11 minus a -1 is going to be 12 on this side. -1 minus 2 is a -3, so it's going to be a -3a on this side. And then, of course, this went to 0, which is what we intended. And so a is equal to what? A is equal to -4. So there's a -4, there's a 3, and that's what we started with. See that? So that's the method of partial fractions. Okay? So the main thing I need to show you is just what structure to start with so that you can then find the constants. So something like this is what you had to do. Let me give you a little practice doing a few more. What if we had this, for example? It's just going to be anything, I don't care what the top is. Say on the bottom you have x minus 1 quantity squared times x minus 5 cubed times x plus 7. Okay? Something like that. You have to allow for the fact that over here you might have had something over x minus 1 plus something else over an x minus 1 squared, right? And then something else, well, here, let me just start. So over here, you might have had something over an x minus 1. You might have had something else over an x minus 1 squared, because if you add those together, you're going to get something with this as your denominator. Then you might have had something over an x minus 5. You might have had something else over an x minus 5 squared. You might have had something else over an x minus 5 cubed. And finally, you might have had something else over x plus 7. So that's your total list of possibilities for what you might have had. And so that's the way you have to write it, and then you can find out what all those constants are. Notice that it's kind of easy to check. If you were to multiply this all out, whatever your highest power of x is, if you were to multiply it out, you're going to get an x to the 5th, x to the 6th here. And that means that there's going to be 6 constants. 1, 2, 3, 4, 5, 6. Okay, it always works out that way. So there you go. So that's the way you'd have to do it. And then depending on what the top is, say this is equal to 4x to the 5th plus 3x cubed minus 7x plus 8. Say it's equal to that. So you multiply through by your whole denominator, and then you use the method that I showed you before to find what all these constants are. Okay? Very good. Now, as I said, you might not have broken it all up into linear terms. You might have had some quadratic terms there. So let's do an example like that. Suppose you have something here, and here you have, say, x minus 3 squared, and here you have x squared plus 3, and here you have x squared plus x plus 3. Okay, just to make a lot of use of 3 there. Okay? These are linear terms, and so these you do just as before. You're going to write it as a over x minus 3 plus b over x minus 3 squared. Same as the previous problem. Here we have a quadratic term. And so the most general thing that you could have over a quadratic term, so that this power is still going to be less than the power here, you could have something with a degree of 1. So you could have, for example, cx plus d over that thing. By the way, notice that this can't be factored, okay? Use a quadratic formula on that, or just graph it. If you were to graph it, you'd see, oh, there's no roots. There's no place where that ever hit 0. Okay? Let me make sure my computer's still working. It's been working pretty well these days. Okay, good. Okay, so you have that, and then finally you've got another thing here. So you've got what? CDE x plus f times the quantity, or I should say over that. Okay, so there you go. What's the highest power of x? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay? What if this thing had been squared? Can you imagine what we would have done? Then we would have had this thing, but then we'd also have to take into account that it's squared. So just like the linear term, I'd go what? Gx plus h all over x squared plus x plus 3 quantity squared. And again, notice that this thing cannot be factored. I can do it in my head easily enough. Just use the quadratic formula, and you'll see that if you try to graph that thing, whatever it looks like, I think it's going to be over on this side, whatever it looks like, it's never going to hit the x-axis. There's no roots to it. Okay, so that's what it looks like. Okay, so that's the main thing you have to know that you haven't seen before in this section is how to write it. Okay. Then, as I say, from there you multiply through by your denominator, and you just have to pick off and find all the constants. So I'm going to do 1 or 2 problems where I do that in a minute. So hold on to your hats for that. The last thing I want to mention is, now that you're done, how do you then evaluate all these things? Okay, let's just say we have these right here. How would you evaluate them? Because now at this point you have to evaluate them. So this one right here, let's just put in a bunch of numbers. Let's make all these 1s and 2s just to make life easy. Okay, let's say a 2 and a 1, 2, 1, 2, 2, 1, 1. Okay, something like that. How would you do them now? Okay, so now you're going to integrate each one. Okay, can you do them? This one's going to be a logarithm, right? Let u equal x minus 3, and you're going to end up with a u on the bottom and a du on the top, and you're going to get an ln of absolute value of x minus 3 with some sort of constant there. Looks like just the 2. Okay. This one here, I'm going to erase it as soon as I do it to give myself space. This one here, I can make the same substitution. I can let u equal x minus 3. And so that's going to be what? 1 over u squared. And so that's du. And that's going to be what? U to the negative 2 du. Antiderivative is going to be u to the negative 1 plus c. Substitute back in, and you're all set. Okay? So no problem with that one. Okay? Are you learning fast here? You can slow this down if you need to and watch it again. What about this one? This one here, you can break up the numerator and write it as 2x over x squared plus 3 dx plus 1 over x squared plus 3 dx. Agreed? What's the advantage of that? Now I can let u here be equal to your denominator. Du is equal to 2x dx, so you're all set. You got 1 over u du, another ln there. What about this one? Recognize that one? That's the one we did. That's the one we did a couple days ago. I can write that as the square root of 3 quantity squared. And if you remember something of this form, the antiderivative is 1 over a arctan of x over a plus c. So this thing right here is going to be 1 over the square root of 3 times the arctan of x over square root of 3 plus c. See that? So that's how that one works. Okay, very good. What about this one? What do we do there? Kind of a nasty looking one. We could start by breaking it up again. It wouldn't hurt to break it up, but it's easier if you leave it all together. And again, all I'm showing you here is just a bunch of algebra, okay? So it's something you haven't seen before. Well, you probably have seen this, but it's just an algebraic trick, okay? Here's what you do. You complete the square. Okay, I tell you what, well, we'll just leave it. We'll just leave it. Dang it. I should have, I'm going to make this I'm going to change it now, just to make it a little bit easier for this particular example. I'm going to make this a 6x plus 13. Let's do that. 6x plus 13. Let's just do that. Okay? That's the advantage of being in charge of things. You can just make changes, okay? This one here works the same way, it's just that these numbers are going to work a little bit nicer. So I'll do this one. So what you do is you complete the square. And by complete the square, if you remember this from pre-calculus, you take half of this number, half of 6 is 3, and then you square 3 to get 9. So you add 9 to it. I really need a 13 there, which means I need a 4 off there as well. Agreed? And now I have 2x plus 2 up on top. Agreed I can do that? Now, why do I want to do that? Because now, I always need my dx here. Now I can write this thing as the quantity x plus 3 quantity squared plus 4. And that's why I did this to it, okay? I teach my pre-calculus class this stuff as well, completing the square. So you take half of this number and you square it and you get 9, so you add your 9 there, and then here's the stuff that you need that's left over. It's always going to be plus something. If this were minus something, then this could be factored. But so the fact that it can't be factored, you got a plus there. Now, what do? Now you can make a substitution. You can let u be equal to x plus 3. Notice that du is going to be dx. And so watch, we're almost done. So now this becomes u squared plus 4. See that? And now, what do I have up on top? I have 2x plus 2. What's x equal to? X is equal to u minus 3. See that? X is equal to u minus 3, so this becomes 2 times the quantity u minus 3 plus 2. Du is equal to dx. And now finally we have u squared plus 4 over, what do we get here? We have 2u, and then what? Minus 6 plus 2 is minus 4. Is that right? Minus 4 du. And now I hope you see this and notice, oh, that's just like this one up here. Now that I got rid of this middle term here, see that? Now I can write it in terms of arctangents and logarithms. Now I can write it as 2u over u squared plus 4 minus 4 over u squared plus 4. And this is going to give me an ln. I can see it. I'm just going to do it. ln of u squared plus 4. You can let t be equal to this, and this is going to be your dt. And here it's going to be an arctangent again. Okay? It's going to be what? Minus 4, here's a 4, divided by, I square root of that, divided by 2, arctan of u over 2 plus c. Okay? So, that's how you do it. Let's see, here's the only one I have left. You could do the same thing with this. Actually, the way you would do this one is you could get it down into this form, except you're going to have squares there, and then you could use a trig substitution. You could use the tangent substitution. Okay, so I'll let you worry about I'll let you worry about that. Okay, I'll do a very simple one. Okay, I'll do a very simple one. Let's just say you had something of the form. Say you had something of the form of 1 over x squared plus, let's say, I don't care, x squared plus 4 quantity squared. Okay? What could you do with that? You could let, remember the trig substitution? You let x be equal to 2 tangent u. dx, this is a dx right there, is going to be 2 secant squared u du. So what are you going to get? Dx up here is 2 secant squared u du. On the bottom, you're going to get x squared, but for x squared, I can put in 4 tangent squared u plus 4. That's all quantity squared. Okay. Now, the 4 can be factored out. When I factor it out, it's going to come out as a 16. This 2 can come out. All those go away. Now I have a, what? I have a tangent squared u plus 1. And tangent squared u plus 1 is secant squared. And here it's secant to the 4th. So it's going to be secant to the 4th on the bottom. Up on top here, I still have a secant squared. Like so. It's going to be 1/8. Can you do the rest in your head? This over this is going to be, this over this is going to be 1 over secant squared, but 1 over secant squared is the same as having a cosine squared up on top. And now you have to use that trig identity and say, oh, what's the cosine squared? Cosine squared of u is equal to what? 1 plus cosine of 2u over 2. So a lot of pieces, okay? These things, did I mention to you, the main reason for doing this is it really gives you a lot of practice at being precise, at being organized, at being careful, knowing your algebra and all that kind of stuff. Okay, good for all of you, okay? Fine, good for you. So that's the idea. So now let me just do a problem or two. These are problems that were on my, have been on my tests from time to time. So let's just find one that works well. I always tell my students that I choose numbers that always end up being 1, 2, 3, or 4. So if they do it right, they should end up with 1, 2, 3s, and 4s quite a bit. So let's just try one here. What's a good looking one? How about, let's do this one. It's 3x cubed plus 7x squared plus 5x plus 20 all over x to the 4th plus 5x squared. Okay? So, let's go through the steps. First step, the degree of the top is 3, degree of the bottom is 4, so we don't have to do any dividing. Second step, we divide we factor the bottom as much as possible. Notice that I can factor an x squared out, and I'm left with x squared plus 5 here. And so I still have this. Up on top. Okay? So now, just for sake of room, I'm going to get rid of this, and I'm just going to write this as equal to, I'll just put a little like this there instead. This thing right here, I'm going to write as what? I'm going to write it as a over x plus b over x squared plus cx plus d all over x squared plus 5, quadratic term. See that? So now we get what? 3x to the third plus 7x squared plus 5x plus 20 is equal to, you multiply it all out. So when you multiply both sides by this whole thing, you're going to end up with ax times x squared plus 5 plus b times x squared plus 5. Notice this one has an x there as well. This one doesn't because I have an x squared in the denominator. And then finally, what? Plus cx plus d times x squared. Agreed? So, how do you find a, b, c, and d? Well, let's do kind of what I said before. We can let x be equal to 0. And if x is equal to 0, on this side, I'm going to get 0, 0, 0, 20. And on this side, this is going to be 0. This is going to be what? If x is 0, I'm going to get 5b. This is equal to 0. Oh, I'm sorry, this is also equal to 0. Everyone agreed? So this is all, if x is 0, that's all going to be 0. That's all going to be 0, and I'm just going to get 5b. So, oh, very good. So I know that b is equal to 4. Okay, so that takes care of that. Now, unfortunately, that's the only one that I can actually do the easy way by just sticking in a number. The other, and this is why I wanted to do this particular problem, the other ones I'm going to have to get by making use of this truism. This thing right here is equal to this thing. I'm finding a, b, c, and d so that this is always equal to this, which means that whatever powers are over here, the exact same powers have to be over here. How many x cubes do I have over here? I have 3 of them, which means by the time I'm done with all this, I'm going to have 3x cubes over here. So here's the way you do it. You just say, I just write x cubed. You look at your x cubes. And you say, okay, I've got 3 of them over here. How many of them do I have on this side? Here, if I multiply this out, I'm going to get a times x squared is ax cubed. So I've got a of them right there. This times this, there's no x cubes there. This times this, there's no x cubes there, right? I'm just going to have an x squared. Here, I'm also going to get an x cubed. Cx times x squared is an x cubed. So I've got c of them right there. So I know that a plus c is equal to 3, but that's still not enough information. I'm going to have to get some more information. Okay, let's look at x squareds. How many x squareds do I have here? I've got 7 of them on this side. How many do I have over here? Here, if I multiply this out, I'm going to get x cubed. This times this is just going to be an x, so I don't have any there. Here I have b of them. See that? And I already know that b is equal to 4. So if I want to, I can just go ahead and put 4 right away. Well, let me just write b, just so that see what's going on. So I've got b of them there. And this is going to give me an x cubed, but this is going to give me an x squared. So there's d of them. Okay? So what do I know? I know that this is equal to 4. So d's got to be 3. See that? So there it is. Okay, well that was useful. Okay, let's look at the x's and see once what happens. if I look at the x's, I'm going to get 5a times x. So, over here, by the way, I'm just going to get 5 of them. I have 5 x's there. Over here, I have 5a times x, so it's going to be 5a of them. See that? 5 times a. Oops. If I multiply this out, I'm going to get ax times 5. So it's 5a of them. I don't have any x's there. And I'm not going to get any x's there. So that's helpful. That tells me that a is equal to 1. And now that I know that a is equal to 1, I see that c has got to be 2, just as I promised. 1, 2, 3, 4. See that? So a is equal to 1, b is equal to 4, c is equal to 2, and d is equal to 3. Okay? So you've just done a whole hooping lot of algebra there to be able to do that. I just feel naked without that little dx there. Okay? So, whoops, I went blank again. Let me make sure I'm good. Hopefully I am. Yep, very good. Okay. So, here we go. I'm going to erase all this now. I've got what I need. And so now, we're basically done, right? This one is just going to be the ln of absolute value of x. This one is going to be plus 4, and then that's going to be what? X to the minus 2, which is negative 1 over x, so it's going to be negative 4. Negative 4 over x by the time you take the antiderivative of that. And then here you're going to get your 2x plus 3. So you remember how to do it? So you can go 2x over x squared plus 5, and then plus 3 over x squared plus 5. And so this is going to be the ln of the absolute value of x minus 4 over x. And here the dx, the logarithm of the bottom is right up there on top, so that's going to be the ln of x squared plus 5 right there. You can let u be equal to that if you want. And finally, this is your arctangent again, right? So it's going to be what? Plus 3 over the square root of 5 times the arctan of x over square root of 5 plus c. There you go. So that's the idea. That's called partial fractions. Very useful. This is really useful in doing lots of differential equations where you sometimes have to find antiderivatives of things like I don't want to get carried away here, but you have differential equations that look like this. dy dt is equal to alpha y times the carrying capacity minus y. I just did this in my differential equation class a couple days ago. So you get dy over y times c minus y is equal to alpha dt, and you take the antiderivative of both sides, and so there's a place where you're going to have to use partial fractions there. Okay? So it comes up quite a bit, and it's a nice, useful technique. So I think you kind of got what you need. So there it is, right there. Next time, oh boy, we start having a lot of fun.